Okay, folks. So today what we're going to do, this should be Monday's video. We got notes, topic 1.112, transformation of functions. And this is going to be 112B. This is the second day that we're going to be doing that. So let me wrap this up a little bit. All right. Now, this paragraph here is actually really important. So I would spend some time with that, reading it, highlighting it. An important aspect of understanding functions is the concept of transformations. Throughout this course, as well as past and future courses, we will study a variety of functions and their graphs. All of these functions can be viewed through the perspective of transformations. Transformations will weave through everything we learn in pre-calc, and they provide a way for us to connect the topics we learn throughout the course. So below is a table of transformation, along with how each transformation affects a graph. Now, some of this is going to be a review, which is fine. It's great to learn stuff more than once. So when we look at these, what we've got here is another way to visualize what I showed you on Friday. So we have a vertical translation where g of x is a different function, where f of x plus k, right? Remember that plus number on the edge of it? So f is a vertical translation of k units. So in this case, if we look down here, we see that it's translated by -2 units. So what that means is that each of our key points has moved down 2 units. It actually looks like the graph is mislabeled, come to think of it, because this comes down 1, 2, 3 units. So that should be down 3 units, right? Here we go down 1, 2, 3 units. Here we go down 1, 2 units. Huh. And then here we go down 1, 2 units. So it looks like Mr. Passwater, who constructed this graph, actually made these incorrect. So this graph should be down here, and then this one should be 1, 2, and then down 3 there. So please fix that. That should be modified like that. Minor mistake, everybody makes them. All right, so now we got a horizontal translation over here. So that's going to be inside the parentheses. F of x is a translation of -h units. Remember, we take the opposite of whatever number is in there. So we do the opposite value. So in this case here, we have x plus 2, which means instead of plus, we would think of that as going to the right. We go to the left 2 units. So let's double check, make sure these are all correct. So we go 1, 2 units. From here in this graph, we go over 1, 2 units. Okay, from here we go over 1, 2 to the left, and here we go over 1, 2. So that's a correct translation for this particular graph. Okay, so the left 2. A vertical dilation. So a dilation is like a stretch or a smushing together of vertical. So in this case, we take a dilation by a factor of the absolute value of a units. Now, in this case, what we see down here is that our vertical dilation is -2. Now, that negative sign, as you remember from Friday, is going to flip it over the x-axis, that horizontal axis, and then it's going to stretch it out by a factor of 2, or push it twice as far away from the x-axis. So let's zoom in on this and take a better look at it. All right, so if we look at this here, we started out here at -1. Well, we're going to flip that over the x-axis and then double the distance away from the x-axis. So instead of being -1 down, we're +2. Over here, we started +1 above, so we're going to flip it over and double the distance. Same thing up here at this point. We're 2 units away above, so that means we're going to be 1, 2, 3, 4 units below. So this is a horizontal or a vertical dilation. And then last one here, again, 2 units above, that means we're going to dilate it to 4 units below. Okay. Now, this one gets a little bit funny. We did this on Friday, where if we have a horizontal dilation of g of x equaling f of b of x, that b number again is inside the parentheses, we're going to multiply x value by 1 over b. We put that in there. So now we check that out, and we see that what this is this is the distance away from the y-axis, this vertical one here. So again, we start out here, and we go 1, 2 units away. So in this case, we're negative. So we're just reflecting that over the axis. So in that case, we start off 1, 2 units away. We're going to start 1, 2 units on the other side. So that negative value just reflects it over the axis, and it doesn't stretch it or compress it at all because it's just a -1x that we're playing with right there. Okay. Same thing with all these points reflected over the x-axis. Now, this table, as we talked about in the past, these boxes that Mr. Passwater put there are really, really helpful. So the first two I love. So we talk about any transformations that affect the x values will occur inside the parentheses with the x variable. And any transformations that affect the x values will do the opposite of what it looks like. Well, what does that mean? That means the same thing that we talked about up here, that if we have a +2 inside the parentheses, we go to the left 2. We don't go to the right 2. And here, if we have this, let me erase all that crap. If we have this negative of x, then what that's going to be, we see that as a -1x, right? That's going to, we take that and we flip it over on the fraction. So that equals, we multiply x by 1 over -1 times x. So that's what it means by doing the opposite. Like instead of multiplying it, we actually divide it by the number that is there. Another way to see this would be just x over -1. So we don't multiply as it looks like it would be inside there. We divide it by the number instead. Now, any transformations that affect the y values will occur outside the parentheses. And any transformation that affect the y values will do exactly what it looks like. So just like we saw here, we had a -3 as our translation. Negative meant we go down, we go down, we go down. And then on this one here, if it's a -2, we multiply the y values by -2. So they flip over and they double. They flip over and they double. Okay, really helpful tips on transformations. Okay, so let's go ahead and do some problems here. Example 1 says, let's get this all in the right area. Let g be a function that has a transformation of the function f. Okay, what does that mean? Basically what it means is we start with f of x. That's the function that we start with. And then we go through some transformation process. And the function that results from the transformation is g of x. So all that means is f is the beginning function and g is the function that has been transformed. Okay? So describe the transformations of the function f that result with the function g. So here what we see is that g of x, and we got this 2, and then we have the f here, and then this x minus 3 and the plus 1. So we can see that the 2, the minus 3, and the plus 1 are the things that have changed f of regular x, right? So we want to imagine that f of x is the normal function. Well, how has it been changed? With this 2, the -3, and the positive 1. Now I have to figure out what they all mean. Well, first off, I see inside my parentheses, those are my x transformations. So that's going to be a shift to the right. Remember, we do the opposite of what the sign says, of 1. So 1, I have an x shift of 3 to the right. All right, what else do I notice? Well, I have a vertical, if I think about this in order, right? Remember H, horizontal, S, stretch, R, reflection, V, vertical shift. So I have a vertical stretch of 2. So I have a vertical dilation of 2. It's a positive 2, so it doesn't flip over the axis. It just doubles the distance away from the x-axis, up or down. And then finally, I have a vertical shift or translation of up 1. Okay, this would be the way that we would describe the way that f of x has been transformed to get to g of x. Okay, let's flip over. On your own, please go ahead and try example 2. All that changed here is that let n be a function that the transformation of m. So again, what that means is that m of x has been transformed into n of x. How has it been transformed? Okay, pause the video. I'm going to start solving in 5, 4, 3, 2, 1. Okay, so now when I'm looking at this, what I'm thinking about is that I've got to consider this in terms of my order. So H horizontal, S shift, stretch, excuse me, R reflection, and V vertical shift. So in order. Horizontal, do I have any horizontal shifts? Well, that would be X minus or X plus something inside. So I don't. Okay, do I have any stretches or compressions? I do. I've got a horizontal stretch or compression inside the parentheses and a vertical stretch or compression outside the parentheses. So my first one is a horizontal stretch of, and I do that the opposite. Remember, it's not 2 times, it's divided by. So it's X divided by 2 or 1/2 of X. Of my X value. So that was the first one. And then my second one is a vertical dilation of 4 times and reflected over the X axis. Okay. All right, let's come down here to example 3. The graph of y equals f of x consisting of 2 line segments and a semicircle is shown for -3 to 5. Okay, so let's take a peek here. We're at -3. Our graph starts here. We got a line segment, a semicircle, and then another line segment, and stops at 5. Okay, so our domain, right, the x values is -3 to 5. Sketch a graph of G on the same axis above, where G of x is f of x plus 3 and then -4. So again, G of x has been transformed, sorry, f of x has been transformed into G of x. Okay. How has it been transformed? Well, inside the parentheses, I have a horizontal shift, right? It affects the x. Anything that's in the parentheses affects the x. And it's +3, so that means it's going to be left shift of 3. And so, sorry, I'm thinking about HSRV, horizontal shift, stretch, compression, reflection, and vertical shift. And then my final one is a vertical shift. So a vertical shift of down by 4. Okay. So all I'm going to do on this is each of these points here, here, and then I'm going to pick one like right up here at the top, so I know how high my semicircle is, and this one and this one. I'm going to do left and then down. So left by 3, 1, 2, 3, down 1, 2, 3, 4. Okay. Here, left by 3, 1, 2, 3, down 1, 2, 3, 4. Well, that's good. They're at the same height because they're at the same height here. And now I go from here, I'm going to go 1, 2, 3, down 1, 2, 3, 4. Okay, that's the top of my semicircle. And here I go down 1, 2, 3 to the left and down 1, 2, 3, 4 to the right. That's the rest of my semicircle. And then I go down 1, 2, 3, 1, 2, 3, 4. And there's my second line segment. Okay, cool. Awesome. All right. Let's see, example 4. Example 4. All right, so here we have y equals h of x. It's got a hole at 4, and it's got 3 linear segments. So k of x is equal to -h of 2 of x plus 1. Okay, so this is going to be flip over the x-axis. The 2x is 1/2 of x, right? We take the opposite. We don't multiply, we divide. So we do 1/2 of x. And then this 1 is going to be a vertical shift up 1. Now we have to do it in order. H, S, R, V, horizontal shift, squish, reflection, vertical shift. Okay. So we have a flip over the x-axis, that's a reflection. And we have a horizontal stretch or compression. And we have a vertical shift. So first is going to be 1/2 of x, which means I'm going to get half the distance to the y-axis, right? If I'm half of my x. And then reflect is going to be over the x-axis. And then vertical, I'm going to go up 1. Okay. So my first point here, I'm going to take this and I'm going to get, if I'm half of my x, I'm going to get half as close to the y-axis. So I'm going to go 1, 2 units as close. And then I flip it over the x-axis. So I'm at -3 here. I go up to +3 here. And then I shift up 1. Okay, let's do that again. So here, I go half my distance to the y-axis. I flip over the x-axis. And then I go up 1. Okay, here I can't go any closer or farther from my x-axis. So then I move over to my second one. I go over the x-axis up to 2, and then I shift up 1. Now I also have to do the same thing with my hole because I want to know where the hole is when I translate it. So if I'm at 4, I'm going to go over to 2. I flip over the x-axis, and then I go up 1. And then finally here, I'm at 6. So I go over to 3. I flip over to -4, and then I go up 1. Okay. Now I'm just going to erase this and make it my hole. I come down here, and then there, over to there, and then up to there. Okay. Awesome. All right. Next. Okay. Now, these get a little bit funky, so please stay on point. All right. So, example 5. Stay with me here on this. The domain from f from example 3 is -3 to 5, and the range is 1 to 3. Find the domain and range of G, where G is 2 of f, x plus 3 minus 4. So what we need to do is we need to think about how our x values and our y values are going to be affected. Well, remember we said the x values were all inside the parentheses. So x moves to the left 3. Okay, well, that's easy enough. We take all of our x values here and we just shift them to the left 3. So our new domain is just going to be -6 is less than or equal to x is less than or equal to 2. I just subtracted 3 and subtracted 3. That's all there is to it. Okay. Our range is a little bit more complicated. So if we think about our range, the vertical shifts always happen last, right? Remember H, S, R, V. Vertical shifts are always last. So we're going to do 2 times our y values first, and then we subtract 4. So if I go 2 times 1, that gives me 2, and 2 times 3, that gives me 6. Now I subtract 4 from each of those, and I get to -2, and 6 minus 4 is 2. So then my new range is going to be -2 is less than or equal to y, which is less than or equal to 2. Okay? So I have to think about how my functions are changing, and then I apply those in the right order to my range and my domain. Next. All right, now these get fun. So stay with me on this, okay? If you need to pause the video, take a break, and come back to it, do that because you don't want to mix these up. Okay, so first thing, the table above gives values for function p at selected values of x. Let h of x be 3 times the function of p times 2x minus 1. Find the following values. Now, this is actually just an algebra problem, so stay with me on this. If I want to find h of -1, all I'm going to do is plug that into where the x is. And my h function is right here. So I have 3 times p of 2 times -1 minus 1. Now I just evaluate this. Stay with me. H of -1 equals 3 times p of 2 times -1 is just -2 times minus 1. Now, this thing here, this p of -2, what that means is what's the y value when x is -2 in this function up here? So really, all I'm looking at is this right there. This is x is -2. So really, I take p of -2, and that's my y value. So this whole rectangular box right here is just equal to 1. So now I go h of -1 is equal to 3 times 1, which is this rectangular box, p of -2, minus 1. Well, 3 times 1 is 3, minus 1 is equal to 2. Okay? Try the next two on your own. If you get stuck on them or need a hint, consult the answer key. Okay? All right. Now, example 7. What we have here is the function g is constructed by applying 3 transformations to the graph of f. So what that means, again, is that we have f of x being transformed into g of x. And they want us to write an equation for g of x in this order: a horizontal dilation by a factor of 3. All right, so horizontal dilations are inside the parentheses. Horizontal means x, so that's inside the parentheses. So g of x equals, oh, they give us this function, this form down here, so I got to follow that. A f times b of x plus c. Horizontal dilation by a factor of 3, vertical dilation by a factor of 4, and a vertical translation by -7. Okay, well, right away, we remember our vertical translations are going to be down here. So we can put that -7 right there because that's the same. And then the vertical dilation, remember, if it dilates the y, that's going to be outside the parentheses. So that's going to be here. And it does the exact same thing, right? A times f of this b of x thing. Well, x is going to stay the same. And the b is the tricky one here. Remember, the horizontal dilation by a factor of 3, we do the opposite of that. So if we were doing the opposite by a factor of 3, what that means is we're really doing 1/3. Remember how we flip it over when it's inside the parentheses? So now we're going to get our final g of x function in that form right there. So a is 4, b is 1/3, and c is -7. Okay? All right. Now, example 8 combines example 7 and example 6. So let's put that all together now. We're not going to do an example 9, so we'll just stop at example 8. The table above gives values for a function h at selected values of x. Let k of x be the same kind of thing we just talked about, where a, b, and c are positive constants. In the xy plane, the graph of k is constructed by applying 3 transformations to the graph of h. So again, h of x is transformed into k of x. All right, so we know k of x is equal to, up here, a of x, or a, excuse me, times h of b of x plus c. Okay? Now, we have a horizontal dilation by a factor of 1/2. That's going to be our b value, which is our horizontal dilation inside the parentheses. And we take the opposite of that. So that's going to be 2x. Right? We flip it over. We don't divide, we multiply. A vertical dilation by a factor of 3. That's outside here. So we have 3h. And a vertical translation by 1 unit, plus 1. So k of x is equal to 3h plus 2x, 3h of 2x plus 1. Find the value of k of -6. Now let's do that. K of -6 is equal to 3h 2 times -6 plus 1. K of -6 is equal to 3h of -12. 2 times -6 is -12 plus 1. Now again, what's h of -12? Go up into my table, right there, -12. H of -12 is 1. A of -6 is equal to 3 times 1 plus 1. Multiplication comes first. 3 times 1 is 3, plus 1 equals 4. Okay, we're not going to do 9. Don't worry about it. All right, that's the notes. Please show your notes to the Ms. Herod, the sub, and then she will give you the homework sheet. And the homework is going to be due Tuesday at the end of the day, and you will have Tuesday in class to use as a work day. Thanks. I know this lesson was a little bit longer. I appreciate you being respectful, taking care of your notes, and